Hi guys, and welcome back to Programming in Objective-C. I'm Yari Dareglia of Jump Zero, and in this lesson I walk you through the basic of ARC, Automatic Reference Counting. ARC was recently introduced to free developers from having to handle memory management. Prior to ARC, handling memory was a tedious task. In fact, it was based on manual reference counting, a task that the developer was responsible for. Thanks to ARC, a big part of that work is managed by the compiler. However, it's important to know how reference counting works because sometimes ARC can't help us. So let's quickly see what reference counting is and how it works. Did you remember the lesson about pointers? Well, I hope so, and I've shown you that creating an object, we allocate its memory, and in Objective-C we refer to this object by pointers. It's possible to run into a situation where more than one pointer points to the same allocated memory. These two pointers need to be sure that the data stored at the memory address still exists until they need it. To avoid a situation where a pointer releases memory that other pointer needs, in Objective-C we use a set of rules called reference counting. These rules are extremely simple. When you create an object using the keyword new or init, or you send the message copy or retain to an existing object, the object becomes the owner of the memory that it points to, adding 1 at its retain count. In this example, the retain count is 3. When we don't need the object anymore, we send the message release to this object, subtracting 1 from its retain count. When the retain count for an object reaches the value of 0, the object receives the message dialog, and therefore its memory is released. Going deeper through this topic is a bit outside of the scope of this course, but I want to be sure that you know what retain count is and how it works. Thanks to ARC, you don't have to handle the retain count anymore. A balance of retain-release calls is handled for you by the compiler, and you just have to define how the compiler manages your objects. Back to the first example of this lesson. In this situation, as I told you before, the pointer 1 and the pointer 2 must be sure that the allocated object still exists. The strong keyword means that the pointer wants to maintain alive the object that it's pointing. So ARC knows that it doesn't have to release this memory until a strong pointer needs it. Another common situation is described by this example. The object player has a property called backpack that points to a backpack object, and the backpack has a property called owner which points back to the player. In this situation, where we use two strong pointers, we get an ownership cycle where the memory can't be released. In fact, each of the objects keep the other one alive. This situation is commonly described as a parent-child connection. In this case, a backpack has no meaning without a player, so the player can be considered the parent and the backpack the child. With this new information, we can now change the connection from backpack to player using a less strict connection called weak. With a weak pointer, backpack is only linked to player, but it doesn't change its retain count. So now player can be released and backpack too. A really important feature of the weak pointer is that its value will be automatically set to nil. So in our example, if backpack is maintained in memory by another object, when player is released, the owner property value is automatically set to nil. A really similar keyword is unsafe unretained. This keyword doesn't change the retain count either, but it doesn't change the pointer value to nil. So to prevent pointing to the allocated memory, you have to do that assignment manually. This type of pointer is used in iOS version prior to iOS 5 and OS X version prior to Lion, where the weak pointer isn't supported. Okay, so now that you know these three new keywords, let's code the player backpack example. Let's create a new command line tool project, and this time be sure to check Use Automatic Reference Counting, which enables ARC. Now, add a new class and name it Player. Then, add another class and this time name it backpack. Open the interface of player and import the backpack header. Now in backpack header we can import the player.h header. But wait, in the player.h we have just imported the backpack.h, so it isn't a good idea to create an import cycle. So we can use the directive add_class to inform the compiler that player is a class and it will be defined at some point in the code. Let's focus on the player class. We add the backpack property using the keyword strong, that for a class variable must be prefixed by a double underscore. You can actually also omit strong, because it is the default type, so in the end we just write backpack star backpack. Now you can add the getter and setter methods for backpack, as you have learned in the previous lesson, and implement them. So add the setBackpack and the backpack accessor methods into the interface, and add the relative code in the implementation file. Just create a setter function to set the backpack and getter to obtain the current backpack. Now open the backpack class and add the player variable, but now using the keyword weak. And then set its accessor methods. So in the interface of backpack we add the prototypes for these accessor methods. So we create the setter and then the getter. And now in the implementation file we can implement these methods. Now open the file main.m and remember to import the player.h and the backpack.h files. In the main function we can instantiate player and backpack object. So player using the alloc init technique and backpack using the same technique. And assign the value to the player's backpack and to the backpack owner, in this case the player. So we have defined two references, but only the player has a strong pointer to backpack, avoiding any retain cycle. This lesson is done, but in the next lesson we continue on with this example, removing the accessor methods and using properties instead, writing your class in a faster and cleaner way. Bye, and thanks for watching.